Hello guys, in this video we will go through the homework problem for the mathematical induction video. Now we have a statement here that says that any number n has a formula that allows you to calculate the sum of the squares of numbers from 1 to n. And we have to prove that. So the first step will be to prove that for n equals 1. And what we have on the left-hand side is 1 squared, and on the right-hand side we have 1 multiplied by 2 multiplied by 3 divided by 6. And that gives us 1 in both cases. So the statement is true. Now the second step is the actual induction. So first of all, we assume that the statement holds true for n equals k. And then our job is to plug in k plus 1 into that formula for n equals k, and essentially to show that the result is the same as if we simply plugged in k plus 1 into this right-hand side formula. To do that, we will first write out the right-hand side formula for n equals k, and that looks like this: k multiplied by k plus 1 multiplied by 2k plus 1 divided by 6. And now we will add the next term in the sequence, k plus 1. So it's k plus 1 squared. See, the number on the left, this formula represents the sum of the squares from 1 to k, and k plus 1 squared is the next term. And what that has to be equal to, what we have to prove, is that it's the same as this: k plus 1 multiplied by k plus 2 and multiplied by 2k plus 3 divided by 6. Let's try and do that and see if our results end up matching each other. First things first, we are going to put our k plus 1 squared into our fraction. And for that, we will multiply the k plus 1 squared by 6. And right off the bat, you can see that there's going to be k plus 1 here and k plus 1 here. So we will factor out k plus 1 from both sides. And the left-hand side is going to look something like this. So it's k plus 1 multiplied by k and multiplied by 2k plus 1 plus 6k plus 1. Divided by 6. The right-hand side, on the other hand, we will try to expand. We will leave k plus 1 out of this since we have it on both sides. And we will expand k plus 2 and 2k plus 3. So let's multiply that, and we get 2k squared plus 3k plus 4k plus 6. Or divided by 6, or that gives us, to put it a little more concisely, 2k squared plus 7k plus 6 plus 7k plus 6. Now with a little bit of luck, we're going to get the same thing on our left-hand side. So let's try to expand this part. 2k multiplied by 2k plus 1 plus 6k plus 1 gives us 2k squared plus k plus 6k plus 6. And lo and behold, it equals to 2k squared plus 7k plus 6. Well, that wasn't too hard, was it? So that means that this term goes here, and essentially our formulas match. They are the same thing, and we've thus proved through induction that the statement holds true. Thank you guys very much for watching. Do not forget to like and subscribe, and stay tuned for more mathematics. See you soon. Bye.